Alright, the point of this video is to help you go from working with just potential energy at the very top and kinetic energy at the very bottom, but points where you actually will have both. In the middle, ME is equal to KE plus PE. Okay, so you will end up having situations where you have both some potential energy and some kinetic energy. So this is going to start out as a review, because typically you need to either be given enough information to find potential energy at the top or to find kinetic energy at the bottom to get your total ME. So we're going to find PE, ME, and KE at every point on this little ramp that our ball is going to go on. So we're going to do it first for point A. All right. So we need PE, ME, KE, and V. So to find potential energy, that's just our normal PE equals mgh. So we're going to take our mass of 5 kilograms, multiply that by 10, and our height for A is listed on the diagram, and that's 50 meters. So that's going to be 50 times 50, or 2,500 joules. All right. Now, technically, in order to figure out ME, we also need to figure out KE, but if KE has a velocity of 0, then we know KE is 0. Okay, so point A, KE is 0. And then ME, since big thing that's always true is ME is KE plus PE, that tells us that our ME is 2,500 joules. All right, so that's part A. That's at the very, very top. And then what's going to happen is we're going to get our ball to the edge. It's going to start rolling down. And then when it reaches point B, PE, our height is 0, so that means our potential energy is 0. Okay? If our potential energy is 0, since we already figured out ME, that's going to stay the same throughout all of these different areas on this system. That's still going to be 2,500 joules. Okay? So our KE then, since ME is KE plus PE, has to be 2,500 joules. So now that we actually have a KE, we can figure out our velocity. So let's get some more room. We know KE is 2,500 joules. If we rearrange the KE equation to solve for V, V is equal to the square root of 2 KE divided by M. So that's going to be the square root of 2 times 2,500 divided by 5. Should be 5,000 divided by 5, which is the square root of 1,000, or 31.6 meters per second. Okay? This is stuff that you've already done. Right? You've already been working with this, should have a handle on being able to do this. What's new is point C. Okay? So let me get this cleared out some. So now that we have some room to work, we need, from what we figured out in A and B before, we know our ME is 2,500 joules. That's going to carry over into C. All right. But now we need to figure out either PE or KE based on the information we're given. We're given a height, so that means we'll be able to figure out PE. All right. So we have height equals 30 meters. Mass is still 5 kilograms. And G is still going to be 10 meters per second squared. So we're going to have 30 times 5 times 10, because PE equals mgh. All right, so we'll have 300 times 5, or 1,500 joules. Okay. Now to figure out KE, you have to use our equation here and rearrange for KE. All right, so since you're adding PE, in order to get it to the other side, you have to subtract it. So KE is equal to ME minus PE. Okay, so we're going to have 2,500 joules minus 1,500,000 joules, which leaves you with KE being 1,000 joules. Okay. So now that we have KE, we can use our V equals square root of 2KE over M to find V. So that's going to look like 2 times 1,000 divided by 5, or 2,000 divided by 5, which is going to be the square root of 400, which is actually equal to 20. Okay, so for part C, we carried over our mechanical advantage being 2,500. We were able to use the new height to solve for PE, and then from there you can subtract the PE to get KE, and then use KE to solve for velocity. One other way that you might see this applied is with, say at this point right here, we're going to call this D. We're given that the velocity is 25 meters per second. What is the height? Okay, this is another way you could use conservation of energy to figure things out. So we already know this is still the same system. Our ME is 2,500 joules. Okay. In order to figure out height, we need to figure out PE, but we're not given the height, so we can't use PE outright to figure it out. So but we're given a velocity, so we can figure out our KE. All right, because our velocity is 25 meters per second. So height is our big question mark right now. So if velocity is 25 meters per second, you can figure out your KE just by plugging in what you know. We know V is 25 meters per second. We know M is 5 kilograms. And we know KE equals 1/2 mv squared. So if we plug that in, KE equals 1/2 times 5 times 25 squared, which is end up being 2.5 times 25 squared, or once you do the math, you end up getting 1,562.5 joules. So 1,562.5 joules. So now we need to figure out PE so we can eventually get to the height. So that's where we need to use this equation again, equals KE plus PE, except this time we want to have PE by itself, so we're going to subtract KE. So PE is equal to ME minus KE, or 2,500 minus 1,562.5, which ends up being 937.5 joules. Okay? So now that we have our PE, we can plug that in to find our height. All right? Because we know PE equals mgh, and if we want to solve for h, we divide by mg. H equals PE divided by mg, which will look like 937.5 divided by 5 times 10, which is equal to 18.75 meters. So some of these problems are going to be multiple steps, all right? The key thing to figuring it out is coming back to the fact that your mechanical energy will always be the same, all right? And then you will also need to be able to utilize this, ME is equal to KE plus PE. All right? You'll always be able to figure out either PE or KE. So you don't want to forget those equations. MGH and 1/2 MV squared will be used over and over. All right? So we're going to practice with this some in class tomorrow. And don't forget to do your online assignment. See you in class.